What?
Fast.
Hi, and welcome to the Space Base. This is your launch pad for all things cosmic. I'm your host, Esmeralda Zamora, and we're exploring a supernova secret that was revealed by astronomers as they witnessed a star's final moments. And to help us explain what that actually means, we have Eric Henrickson here, giggling as always in the corner.
Well, we're your launch pad.
We are.
I do appreciate. I just didn't expect you to throw that.
This is our rocket ship. Can you tell?
This is very. Ooh, I like the shot. Yeah, very rocket shippy. This is probably about the same size as a lot of rocket ships.
Really?
Yeah, they're kind of.
This is tight. Then.
This is tight. And imagine living in here for months on end.
I don't want to imagine that.
Admittedly, if you're in space, you get to float up. So you also have that too.
Yeah, you do. We would probably hit our head on these lights. But
I hit my head on the light anyway.
That's true.
Multiple times. I'm 6'6". I walk through this room and smack my head on these lights. That's the vibe we're going with. Injured heads, a little blood trickling down. But we'll talk about supernovas instead.
Well, that's kind of similar to what the stars experience, right?
What are we? We are already off on a start. So let's start. I'm gonna try to take a firm grasp and lead us in. Supernovas. Sorry, guys. This is a very silly episode. Supernovas. So some researchers out of Texas, one of which was a graduate of Texas A&M, now working in China, one of which is a retired professor at UT. His name is J. Craig Wheeler. I got to interview him. We'll show you that in just a second. They got this new discovery when it comes to supernovas. Really, really cool thing is that the way supernovas occur, it's a star that's in its last breath, and when it dies, it explodes, but we don't really know how they explode. Like literally, we haven't seen it, and we finally witnessed one via telescopes. The star is called SN 2024 GGI.
It's so cute.
I like the GGI on it. I think it's really, really cute. I actually was thinking the same thing earlier. And this star, it's several million light years away. I think it's like 20 million light years, 22 million light years, something like that. Let's say 22. So 22 million light years away, pretty far. But one of the researchers saw that it was going to go supernova, and they made a quick call to the European Southern Observatory, which is an observational post in Chile, and said, hey, we got to get eyes on this thing. And they were able to witness a supernova in the early stages, which we haven't seen before. And so I got to speak with J. Craig Wheeler, and we're going to show you that interview right now. What is a supernova? What exactly is happening in a supernova?
Yeah, well, there's a couple of different flavors of them. Some of them are tiny stars that the sun will evolve into, will blow up in one way. And the kind we're talking about here are more massive stars, very much like Betelgeuse, which is another passion of mine. They undergo thermonuclear burning, so conversion of hydrogen into helium, and then helium into heavier elements like carbon and oxygen, and then silicon, kind of odd elements, but there's a reason why there's these particular ones. Silicon, and they finally make iron. And it turns out iron has a nuclear property that it cannot liberate any energy. It can only absorb energy. And so once you've made that iron core, it starts to absorb energy. That reduces the pressure. That takes away the support of the star, and the whole inner core collapses. And it'll collapse down to make a neutron star. So something with the mass of a star and the size of Austin, just a few miles across. And so you imagine this immense falling inward. There's a tremendous amount of energy liberated in the process. A lot of it leaks out for technical reasons I won't go into unless you want to pursue them. But enough of that energy is redirected outward again. So it's very qualitatively a bounce, but it's a much more complicated process than that. And it sends energy outward and blows off the whole outer parts of the star. So it's a very dramatic explosion. The star will, for a brief interval, be as bright as the galaxy it sits in, made of trillions of stars. It's a very impressive event, if nothing else. So if you like explosions, these are some of the biggest in the universe.
So with this new discovery, I was reading about it. It's more about we've learned more about the shape the star takes.
Yes, no, the shape is the key to this particular development. So stars, gravity pulls in all directions, and that basically makes the star spherical, round. and evolves most of its time that way. But we have had hints going back 30 years now that I've been dabbling in this, that when these massive kinds of stars that we're talking about, 10 times the mass of the sun, 20 times the mass of the sun, stars like Betelgeuse, blow up, that they are not spherical, that something despherizes them as they blow up. And there are questions of whether when this neutron star forms, it's spinning and it sends a jet of energy up the rotation axis. And so it blows out like upwards and downwards, not equally in all directions. And we've had hints of that before. But in this particular case, we've been refining the techniques of measuring the shape for several decades now. We've developed those techniques and gotten the reputation that we can get the telescope time to do this kind of thing. There's a whole political scientific background to it, where we can get frequent observations. And that's basically new. We used to get one observation of a shape of one supernova. And then we've gotten to the point where we can get a couple of observations and we can sample different kinds of supernova. But we finally gotten, after decades of struggling, that we can get, in special circumstances, very early, very frequent observations. Now, this we would have liked to have done all along, but the community of astronomers have other things they would like to do with the telescopes. Thank you very much. So you've got to compete your way into that. And then the fact that this one evolved, that my young colleague E. Yang, who got his PhD at the Texas A&M University, by the way, so he's working now in China, but he's part of the Texas Mafia at some level. But E had just flown from China 14 hours overnight and landed just as the supernova was discovered. And he had the smarts to get in touch with the telescope operators in Europe and say, we need to look at it now. And we had enough of a reputational clout that they acknowledged that. So we got observations within hours after the supernova exploded. It was an unprecedentedly early event. And then we followed it fairly frequently so we could see how it changed shape as it expanded. And it's definitely out of round. It's definitely blowing up in a certain direction. It's not round. Again, we had suspicions of that before, but this is the best series of observations ever made to confirm that. And then, if I can elaborate just a little bit more, the star itself was round, but we deduce, and there are reasons for understanding this, if there was a binary star that put matter over onto it that spiraled around like a disk. And the supernova started off blowing up the axis, but then expanded outward and ran into this disk of material. And that keeps the same general symmetry, but it's now it started off as a football shape, and now it's more a frisbee shape. We could really tease out what these shapes were, and they were definitely not round, and they interacted in a very specific way that we managed to map out for the very first time ever. Thank you very much.
Where does this take us next in our discovery of the cosmos? What does this information provide us?
Yeah, well, so supernovae really are connected to everything in the cosmos. So you see these giant explosions relatively nearby. This was 22 million light years away, but by astronomical terms, this one was nearby. But we see them all the way across the universe. We've used supernova to discover the fact that the universe accelerates, driven by a dark energy. That's a supernova result. The elements in our bodies, the calcium in our bones and the iron in our blood, all come out of exploding supernovae. So it's life depends on them. So there's implications all over the place. That's the general case. In the specific case, we have now made a case that, look, if you give us enough telescope time, we can do amazing things with it. So we will be going back and asking, to be set up, and we don't know when these are going to blow up. So you can't really plan in advance. You've got to be ready to really react very quickly, which is what Yang did in a marvelous way.
He was so cute.
I know he was. We were talking about how he'd be a great professor. He was a former retired professor from UT.
Yeah.
He'd been a great professor because the way he described things were. I thought it was fascinating.
So fun. Like
That animation at the end that was made by the European Space Observatory for this specific explosion. So that is the rest were other ones. That one that we showed have one other time is this exact explosion. They animated it to show you how it kind of blows out. But the way he described the thing I thought was most fascinating was he talks about how the stars create iron, and then the iron absorbs the radiation, which causes the stars to collapse. So the stars literally create their own destruction over billions of years.
and
Right.
it looks like a bunch of little stars come out of it when it explodes.
Yeah, it's like that kind of explosion where it's like bubbly because it ruptures. The way they described it is the star ruptures as it explodes, and then when that rupture occurs, it's almost like a balloon popping or something. Like it collapses on itself, but also because of that, and then out.
Wait. Can you do that again?
Yeah. I have Emmys. I don't know what's going on with me. Like that. That's literally what it does. So, gosh.
That was priceless. Better
yeah.
than the graphic that he showed
Thank
us.
you. Yeah, I think the hand gestures is really what sells it. So anyway, I thought it was just really cool. And these researchers, I call them in my web story the Texas Mafia.
I saw that.
He referred to them as the Texas Mafia. So, but I just thought it was a funny way of putting it. There was one other researcher involved who I kind of trimmed out the interview there, who was also from Texas A&M.
Wow.
So we have a bunch of it's like Texas A&M UT people all working together overseas, working with the European Space Agency, European Southern Observatory to do this discovery. Really cool. We always talk about how we're made of stardust, and this is just how we're made of stardust.
And
Supernova
this is
occurs
how
and-
stardust becomes stardust, right?
Right. Yeah. It explodes and becomes stardust, and that stardust becomes the building blocks for everything that ever was and ever will be. So pretty cool. Death begets life, I guess.
Death by star.
Yeah. Pretty
Well,
cool.
it's exciting that we got to see this, and how did they know that this was going to happen? You mentioned that they called.
They saw the supernova was going to occur, and then they made the phone call and go observe this. So they knew they could see the early signs of a supernova. We were lucky to capture it when they did. Getting the telescopes in the right position at the right time, having them available. Very hard. People are fighting over those telescopes.
Yeah.
So this is luck and also ingenuity, and good work from the researchers to make that phone call and say, "Hey,
Get on it. Yeah.
we need to move this right now."
Well, this is not the only thing we're talking about. The supernova is the biggest thing
About as big as you can get.
that we
Yeah.
have on our list of topics, but we're also expanding more on the European space side.
Politics. Let's talk
Politics.
politics. So this is the politics of space. So we talked about the European Southern Observatory, which is the telescopes. Now let's talk about the European Space Agency, which is basically Europe's version of NASA. They announced this past week that they're proposing a $22 billion budget.
That's a lot.
Not dollars, euros. 22 billion euro budget for the foreseeable future. That's a 30% increase in their budget. And their argument is they're saying there's a bunch of security threats. There's all these other groups that are moving towards space, and they need to be in space. Europe needs to be in space and have a strong foothold in space. They called it, quote, a perfect storm of security threats with Russia's war in Ukraine and then more people becoming automated in space. It's just they need to make sure they're ready. They emphasize the role space plays in modern defense, and that's part of the reason they're kind of doing this. Some of the things I thought were interesting, they want stronger independent capabilities, 2 lunar missions, Argonaut and the Moonlight. They're trying to get on the moon too. And they're still going to work with NASA. They work on the Artemis program. But in the U.S., defense spending accounts for globally, defense spending accounts for 50% of the defense spending budget goes to space. But in Europe, it's only 15%. So they don't put as much defense money towards space as the rest of the world does. We do 50%.
Yeah.
That's that's not telescopes. Satellites, that's missiles, that's all those other things you put in space.
All that you
Modern
need
equipment.
to
Right.
get to where you want to go. And we're all trying to get to the moon. Is that what Europe is trying
It
to do?
becomes a race for military is the thing. It's all about at the end of the day. It's all about it becomes a military thing. It's can we get to the moon where we can have better control over the skies over the Earth, in control. It becomes a
Control the
security risk.
moon, pretty much.
Control the moon. It becomes all about security. You know, that's. I was listening to Neil deGrasse Tyson talk recently, and he was saying that, you know, the reason we went to the moon is we had to beat the Russians there because we had the Cold War with the Russians, and now the new race to beat China and Russia back to the moon and India back to the moon it's the same thing. It's kind of a military race to get there. Yeah. One of the things holding us back from Mars is we don't really have a military reason or a financial reason to go there, where we do have that on the moon.
Yeah.
So that kind of is pushing us, and now Europe's like, we are getting in there. We want more money to do this. Josef Arschbacher, who is the Director General of the European Space Agency, he told member states the time for a, quote, thought and concern is over, and Europe must act or fall behind. And he talked a lot about, you know, the need to get on the moon itself, and we actually have him saying that. We can take a look at that.
As the United States, China, and India fly to the moon, we will jointly make sure Europe will not stay behind. The moon is our next destination, where the Argonaut and Moonlight missions will secure us a position in the global lunar race. Our contributions to NASA's Gateway are a crucial asset for international cooperation. Without ESA's European service modules, Artemis astronauts, including European ones, would not fly towards and to the moon. We are not a sidekick, we are protagonists in humanity's return to the moon. Minister. Allow me to be crystal clear. The era of thoughts and concerns is over. We are now in the period of action and consequences. To stand still is to fall behind. So let us place our faith in our own capabilities, in our own ingenuity, and in our own industries. Let us deliver what is expected by us.
So they feel that they're falling behind,
right.
Pretty much?
They feel like they're falling behind. All these other places, China, Russia, the U.S. is making this big push to deep space.
Yeah.
And they're like, we need to get the billions of dollars. We increase our budget by a third.
Yeah.
To get up ahead. I honestly don't know why he had kids in that last photo.
I was about to ask you.
There was no. I didn't see. I was trying to figure that out too, and I didn't see the part in the speech.
Maybe they want to like push education, more space education.
Probably, and to help boost it. So the European Space Agency is funded by multiple European countries. So they're all working together to hopefully boost that together. So that's where that can come from. And
we are still going on our trip around the world. Now we're going to talk about the Russians.
I did plan this well, by the way. I thought this through. Yeah, so a U.S.-Russian crew launched aboard the Soyuz rocket last week. This is the crew. There's 2 cosmonauts and 1 American astronaut, Chris Williams. They boarded the Soyuz rocket from Kazakhstan and launched out of there. We get to see the rocket here launch.
Cosmonauts, is that what they call them?
Yeah, that's what their names. I forget the Chinese have a different name for their astronauts too, but cosmonauts is the Russian one. But they launched. They're going to spend 8 months aboard the International Space Station. There's that rocket launch. Isn't that cool?
Is 8 months like the basic amount of time that they have to?
China does 6 months. This group's doing 8. I think it really just varies on the mission. I know it varies on the mission. I don't know if there's a consistent time there, like this is the regular amount of time.
It seems it's like between 6 and 8. Like
that seems pretty consistent. I think some, we had a couple astronauts who have spent like a year in space, and
too long.
I mean, for you, if I wasn't married, I could probably do it. But it's because they were doing that to see like the physical toll it takes. They docked at the ISS 3 hours after takeoff, so about a 3-hour trip. Not too bad. That's here to Corpus, isn't it?
No, Corpus is like maybe 3.5.
3.5. Yeah, that's not too bad. So you could drive home to the International Space Station.
Wow.
That quick.
And then they have to stay there in the International Space Station.
Yeah, that's cool, right?
In a room this big? No way.
Well, the International Space Station has multiple rooms this big.
Oh, okay. Then that makes
like
sense.
10 or something. I don't remember how many. I've seen flying tours. We'll let this video play because it does show the International Space Station here in a second. Currently aboard the International Space Station are astronauts from NASA, Japan, and Roscosmos, which is Russia's space program. So Japan and NASA are up there right now.
The Japan astronauts are the ones we spoke about last week, right?
China astronauts.
Oh, those are the China ones.
Chinese astronauts were last week, Japan astronauts this week. But they're just on board.
But are the Chinese astronauts on our space station?
No, they are not allowed on the International Space Station because there were security concerns, which is why they have their own space station, which went up in 2021.
So they're going to continue to stay separated from us.
And when we say separate, we're talking about hundreds, if not thousands of miles away. They're not near each other. We talked about this before, but you've seen Gravity where she like floats from station to station. That's not possible.
Not
These things
true.
are really far apart. Like you would not be able to do that. That movie's still cool. That is not possible. NASA astronaut Chris Williams will conduct scientific research and technology demonstrations looking for future space exploration that benefit Earth-based science. I don't know what that means, but that was the bullet point we were given. So he's looking forward, deep space missions later on. All the stuff that our crew is currently working on is like, let's get to the moon.
Yeah.
Like we're building towards the moon. Every little mission at this point is building towards the moon and establishing a colony there, hopefully.
And they're also looking to grow their own like food and resources so that they can stay longer.
All that stuff.
Right?
Yeah, they've been doing research on that for years, but they're definitely ramping that up. It's all about, how can we stay there longer? The moon, we believe, has water on the South Pole. And if it does, we can make that liquid. Not only does that give us fuel, but it gives us resources for water and for food and stuff like that. And so if they can start doing that in the International Space Station, where they can get stuff to them relatively easy, once we get to the moon, it's a lot less challenging.
Yeah.
And the moon isn't, it's far, but it's not that far. It's like a week flight. I'm about to cough. I apologize.
A week?
Yeah, a week. It's not that bad.
Oh, wow.
When you compare it to Mars, which is like 3 to 6 months, depending on how fast you're going.
Well, I'm down. Let's go to the moon.
If
it only takes a week.
If we can do a week, so it's a week there. If you stay so like I have a general rule that like based on the length of travel, when you're at a location, you need to have like more, like it's like double that, right?
Yeah.
So you want to do, so it's 2 weeks, 1 week there, 1 week back. So you want to do at least a month.
So you can stay there for like 1-2 weeks, and then you have 2-week travel time?
No. I would do 1 week there, 4 weeks on the moon, and then a week back. Yeah.
Wow.
Just because the length of time. No, I'm sure after like
You don't think you'd get tired?
5 days, I'd be tired. But like,
I would miss home.
Once you pay for the flight, you might as well spend some more time there. The flight's always the most expensive part.
Yeah.
That's kind of a general rule of thumb.
But they don't have chocolate on the moon. They don't have...
They have chocolate on the moon. Well,
Do
not
they?
now, but yeah, you can ship that stuff up there.
They don't have a Chick-fil-A on the moon. How are you going to last for 4 weeks?
I'll be fine. I'll be fine. I like Popeyes more anyway.
Oh, okay.
Love
We
it.
can take
Love
it
that
with
chicken
you.
from Popeyes.
Well, we have that article on our website that you published on the supernova.
Yeah, I have some more quotes there, some more information on the research, a link to the actual article if you're like the actual research if you want to look at that. Pretty simple. And I have a cool photo of that animation.
Cute little name.
Cute little name. The cute little name, SN 2024 GGI. So
IGGY, like Iggy?
Yeah. GGI, not Y though.
Oh, yeah, IGGI. Well,
IGGI.
before we wrap things up, I do have a question for you, and I want you to answer as honestly as you can.
Okay.
Ready?
Yeah.
Are you a round earther or a flat earther?
I'm a round earther.
Really?
Yeah, why would I be a flat earther?
Why wouldn't you?
Because the Earth's not flat.
But how do you know?
Because we can see it from space.
Is that true?
Yes. Yes. Also, I need to be careful because I know some people get up in arms about this, but
yeah,
like
people get upset.
It's a fact. You can also measure the orbit of the Earth, like from the Earth. They've been doing it since ancient Egyptian times. They would take a stick. I know this from science class, but they would take a stick and they would measure it over the course of a year and use the length of shadows to change to determine the Earth was round. We've known the Earth is round. Well, I gotta be careful. We've known the Earth is round for thousands of years. When they were traveling from Europe to the Americas, they knew the Americas was there. They also knew that on the other side was Asia. It wasn't like, Americas were a surprise.
Yeah.
So like we've known, and they knew it was round. Now, there are dimensions out there where it's a flat Earth and we're on top of a turtle who's on top of an elephant and and then that's on top of a turtle and it's turtles all the way down.
What?
But that's a totally different multi-dimensional thought process. But on our Earth, in our universe, the Earth is round. All the planets are round.
So where did the discussion of a flat Earth come to be?
I have no idea.
Because when you're in the ocean, you don't all of a sudden drop down. Here
is the problem. We don't understand as a species how tiny and insignificant we are. We are. We're just very small. The Earth is very big. You know how I can prove this?
How?
Go drive to Corpus Christi. Takes 3.5 hours.
Takes 3 drive across Texas.
Drive across Texas. It takes a day and a half. We are small, insignificant creatures on the scope of the planet who can make a big difference and make big changes because there's a lot of us and we think we're intelligent.
Yeah.
But we're a very small species. It has a lot to learn and a lot to grow, and the universe is vast and far beyond us. So yeah, the Earth's round.
There,
The Earth's never been flat.
Eric is a round earther. I am too. I don't understand the flat Earth
You
theory,
made me
but
really concerned for like a good solid 2
I
minutes
just wanted
there.
to hear your take. I knew you were going to say round. I just wanted to hear why.
Yeah, I have takes. I have takes on everything. I have to be very careful. That's
Well, thank you for
that's
joining.
what editing's for.
True. Thank you for joining us, and we will see you next week.
See you next week.